Okay, let's begin. Now know that whenever you want to solve differentiation questions with Casio calculator, the calculator should always be in reduce mode to avoid unnecessary error. Very important point. Also know that the number of brackets at the right hand side must equal the number of brackets at the left hand side. Another important point. We get to see the application of these points as we progress into the practical aspect of this video. Now note again that first derivative can also be represented as y prime or the y over the x in the question. Very, very important, because the examiner may choose to use y prime or the y over the x in replacement for first derivative. So don't get confused. The three terms mean the same thing. Okay, having known that, let's look at examples under this topic and solve them together. So example 1 here says, if y equals s squared plus 3, and brackets again, s raised to the power 5 plus 1, what is y prime? As you can see, they chose to use y prime instead of the y over the x. So they all mean the same thing. So right now, let's bring the calculator and solve this example together. Okay, so the first thing you have to do here will be to clear the calculator. Very, very important. The essence of clearing the calculator is to avoid unnecessary error, because you might not know whether you have performed a previous calculation in the calculator. So to be at a safe side, you are advised to clear the calculator. Right now, we clear the calculator, and to clear the calculator, the first step will be to press Shift and this button 9. You follow the instruction. Want to clear all, press 3, equal to yes, and press equal to again. So the calculator has been cleared. The next step will be to put the calculator in reduce mode. And to do that, you press Shift and mode. Option 4 is reduce. So you press 4. The calculator is now in reduce mode. So the next thing now will be to store a value we use to differentiate this function. You can choose to store any real number like 2, 3, 4 in that order, but I will advise you to store 2, to always work with 2, because personally I've worked with 2 for a long time and I have not found error with it. So I will advise you to also be working with 2 to be at the safe side. So right now we're going to store 2 in this calculator. And to store 2, the first thing you have to do is to press the number I want to store, which is 2. Then press Shift, this button written IOCL on, which represents store. You press it and press alphabet X. So once you do it, this indication will show you that 2 has been stored as X in this calculator. So you wipe it and impute these values in the calculator. Normally you can solve this kind of question with product rule if you want to show all working, but we don't want to show all work. We want to learn how to do it with calculator. So having done all the necessary things, let's impute these values now in this calculator. So the first thing will be to bring out the differentiation symbol. To do it, you press Shift and this integral sign on this button. So once you do it, it will come out, divided by the s will come out. So you impute the values. The values here is starting with brackets, so you open a bracket irrespective of the bracket already there. So you open a new bracket, so you put s squared. To bring out x, you have to press alpha first. If you press x before alpha, it will not come out. Or if you press S alone, it will not come out. So you have to press alpha first before you press X. So S square plus 3 equals a bracket, open a new bracket, and press alpha X. That will have X raised to the power 5 there. You use this power function and come down plus 1. So you close the bracket. As you can see, the number of brackets at the right hand side equals that of the left hand side. There are 2 brackets here, and there are also 2 brackets here, so they are balanced. So you go back to this place and put 2 you stored in the calculator. Once you do, you press equal to check your answer. So we have 692 here. So what we do next now will be to evaluate each and every one of these options to see the option and give us the same value we have gotten here. Okay, before we evaluate each and every one of these options, let me show you something why you should make sure that the brackets are balanced. So if you go back now and remove all of these brackets, delete one, as you can see at the right hand side we now have only a bracket. At the left hand side we have 2 brackets. So if you press equal to now, you get mass error. So it's very important to balance the brackets so that you not have this kind of error. Very important. So right now we wipe and evaluate option A. So option A here, we now have to store a new number, so we have to make use of the original number, which is 2. We have stored in the calculator to evaluate each of these options. So let's evaluate option A now. We have 7x, which is alpha x raised to the power 6. Use this power function, come down, plus 15x, which is alpha x raised to the power 4. Use this power function, you come down, plus 2x. So we have alpha x. So once you have done this, you press equal to. So we have 692. So this is the same value we got after differentiating. So this option A is definitely the answer. So this is how you can solve derivative with Casio calculator. And even we evaluated this option A and didn't get this same value, we would have gone to option B till we get the option that give us 692. And even we did it for A, B, and C and none gave us this 692. The answer would have been option D, which is none of the above. So that's how you can solve this problem with this calculator for multiple choice questions. Now let's do one more example. So example 2 here says, if y equals x minus 1 over x plus 1, what is y prime? So as usual, we won't have to clear the calculator because we are still solving the same question under the same topic. So we are still solving a similar question under the same topic rather. So what we have to do now will be to impute these values in this calculator. So to do it, we will press shift this integral sign button to make that the y over the x. So impute the values. So using fraction, so we have x alpha x minus 1 all over x plus 1, which is alpha x plus 1. Then go back to this side and put the 2 we have stored in the calculator. So press equal, have 0.2. So let's take the option that give us 0.2. So option A says 1, which is not the answer. Option B says minus 1, which is not the answer. So let's evaluate these options C and see what it will give us. So in fraction, we have 1 over, in brackets, x alpha x plus 1. Let's press equal to 1 over 3. You change this to decimal. To change it to decimal, you press this SD 0.3, which is not the answer. We got 0.2. So let's check option D. To save time, I simply go back and remove this one and replace it with 2 and come down. We have square here, so that we press equal to, you change it to decimal, you press SD 0.2. So this option D is the answer to this question. So guys, that's how you can solve derivative, particularly first derivative, with Casio calculator. We are going to look at the tricks I use to solve differentiation questions involving second and third derivatives in a matter of seconds, especially for multiple choice questions. Now, after going through this video, you are going to learn about these tricks I use and also become able to apply them on your own effectively. Okay, let's begin. Now, note that when you want to solve second and third derivative questions that have options, the highest value in the options is usually the answer. A very important point. Also note that if the questions happen to be in trigonometric form, the lowest value in the options will be the answer. Another key points. So take note of these 2 points here. Now note again that second derivative can also be represented as the 2 y over the s2 or y double prime. Y third derivative can also be represented as the 3y over the s3 or y triple prime. Very, very important, because the examiner may choose to use this term, the 2y over the s2 or y double prime, in replacement for second derivative, and also for that of third derivative, the examiner may choose to use the 3y over the s3 or y triple prime in replacement for third derivative, respectively. So don't get confused, they all mean the same thing. So having known this, let's look at the example we have here and solve it together. So example 1 here says, if y equals, in bracket, 4x minus 3 raised to the power 5, determine the value of the 2y over the s2 at s equals to, as you can see here, they use the 2y over the s2 instead of y double prime, so they all mean the same thing. Don't get confused. So merely looking at these options, option A is 500, option B is 2500, option C is 5200, and the last option is 40,000. Now, merely looking at this option, from these first points we noted, when you want to solve second and third derivative questions that have options, the highest value in the options usually answer if the question does not involve a trigonometric symbol. So you can see here now, the highest number here is 40,000, which is the answer to this question. Now this is the trick. The highest value here is 40,000. So this is the answer to this question. But we're going to confirm this 40,000 with another trick using the calculator, that you will not doubt that this option D is the answer, right? So right now, let's use another trick again to confirm that 40,000 is indeed the answer to this question. So let's bring the calculator and use it to solve this differentiation and see if we get 40,000, right? So yes, use it to solve this second derivative question. So the first thing we have to do will be to clear the calculator. Very important. The essence of clearing the calculator is to avoid unnecessary error, because you might not remember whether you have performed a previous calculation in this calculator. So to clear your doubts and be at the safe side, we advise to clear your calculator to solve a new question, right? So right now, to clear, we press shift this button, and so to clear, what you have to do is you press shift and button 9. So the instruction, want to clear, also you press 3 equal to again. So the calculator has been cleared. The next thing we have to do now will be to put the calculator in reduce mode. Very, very important. Whenever you are solving differentiation with the Casio calculator, make sure that you put the calculator in reduce mode to avoid unnecessary error. Right, so to do that, press shift mode, option 4, reduce. So as you can see, the calculator is now in reduce mode. Right, it was in degree before, but now it is now in reduce mode. Right, so the next thing now we do now will be to store these two as s in the calculator. Had they didn't give any value for x, we would have still made use of 2, though you can use 3 if they didn't give us any value for x. You can use 3 or 4 or any other number, but I advise you to still make use of 2, because I've worked with 2 for a long time and I have not found error with it. So right now, since they have already given us the value of x here to be 2, so no need of insisting on 2 again. So we go ahead and store these two they have given already as x. So to store these two, what we do now will be to press the number first, 2, press shift, store this button that has RECL, then press alphabet X. This arrow indicates that S has been stored as 2 in the calculator. So once you do it, you wipe and impute these values in the calculator. So the first thing you have to do is to bring out the differentiation symbol. To do it, press shift, this button that has integral sign on it, it will come out divided by the x. So input the values is starting with brackets. So you open a bracket irrespective of the one already there. So you put 4x. To bring out x in the calculator, you have to press alpha first before x. If you just press only x, it will not come out. You have to press alpha first before x. So you have 4x minus 3. You close the bracket, raise to power 5, use this power function, and come over to this place and put the 2 we stored in the calculator. So we press 2 and press equal to. So we have 12,500. So what we do now is to store this value as alphabet A in this calculator. To do this, what we do is to press shift, this store RCL button, then alphabet A, which is this one. Now answer stored as A. This value 12,500 has been stored as A in the calculator. So we move up to go back to the question after storing this 12,500 as alphabet A. So we move up, go back to the question, come over to this place and add this constant. I'm going to say now here, which is 0.00001. So this is a constant you add here. So after adding it, you press equal to, and you get this value 12,500.4. So you store this value as alphabet B in this calculator. So to do it, press shift, store, then alphabet B, Now this value has been stored as B in this calculator. So after doing it, you wipe the calculator and do the next thing. So the next thing we do now will be to bring out the values we have stored in the calculator for A and B respectively. So we subtract A from B and divide it with the constant we impute, right? So what we do now will be to bring out alphabet B. So to bring out alphabet B, press alpha B minus alpha A all over the constant we impute by differentiating. So we have 0. So we have 0.00001, right? So we are done. Now we press equal to and see if we get 40,000 as an answer, right? So right now we press equal to. So we have here 40,000.48. So we are indeed correct with the tweak we applied here initially. So 40,000 is the right answer to this question. So guys, this is how you can use these two tricks to solve this kind of question under second derivative, right? It's also applicable for third derivative. So right now let's solve this next example we have here. Okay, now as we did here, this question says find the 3y over the history of in bracket 1 plus x over 1 minus x. Now, knowing that the answer to this question will be the highest value in these options, but now the values in these options are not in whole numbers like here as we have it here. They are in alphabets. So what we have to do now to remove these expressions we have here in figures and also in alphabets will be to evaluate each and every one of these options using a stored value for x, which we have already stored while we differentiated this with the calculator. We stored 2 in the calculator, so right now we don't have to store any other value. We still work with that too to evaluate each and every one of these options. So right now let's evaluate option C, which is the answer to this question, because I've solved this particular exam before. To save time, the answer to this question is option C. Right now let's evaluate option C, or let's do it all together so that we know their respective values, right, before concluding that option C is the answer. Right now let's do this fast. So we have 2x alpha x, bring out x over, in bracket we have 1 minus x alpha x equals the bracket raised to the power 3. So we have minus 4, option A to be minus 4. So let's check option B. So to save time, I simply go back and option A is minus 4. So we have 2x minus 1 all over. You come down and remove this power. I replace it with 4. Right, so we press equal and see what we get. 3. So option A we got minus 4, option B we got 3. So let's check option C. I simply go back to save time and delete these figures or values and replace it with 12. So that's it. We press equal to. We have 12 as the answer. So option A we got minus 4, option B we got 3, option C we have 12. So let's check the last option. So we go back and remove this 12 and replace it with 6. Then come down and replace this power with 3. So minus 6. So option A, we got minus 4. Option B, we got 3. Option C, we got 12. And now option D, we're having negative 6. So the highest value in this option is 12, which is option C. So I was correct. So the answer to this question is option C, which is the highest value in these options according to the points we noted here, right? So guys, these are the tricks I used to solve questions involving differentiation on second and third derivatives, especially for multiple choice questions. I hope you learned a lot. Now, after going through this video, you'll be able to solve trigonometric differentiation with Casio fx-991 ES plus calculator easily. Okay, let's begin. Now note that in trigonometry, cosec theta is the same thing as 1 over sin theta. Sec theta is the same thing as 1 over cos theta. Cot theta is the same thing as 1 over tan theta. Very, very important. We're going to see the application of what we have noted here as we progress into the practical section of this video. Okay, note that in this video, we'll be replacing theta with x as we move into the calculator aspect of this video. So we'll be replacing theta with x in the calculator. Having known that, let's now look at the examples we have here and solve it together. So example 1 says differentiate the function y equals cos theta over sin theta with respect to theta. We have the options here to be option A minus sin squared theta, option B minus cos squared theta, option C none, option D sec theta. So right now let's bring the calculator and solve this problem together. So the first thing you have to do will be to clear the calculator. The essence of clearing the calculator is to avoid unnecessary error while solving, because you may not remember whether you have stored a previous value in the calculator. To clear your doubts and avoid unnecessary error, you are advised to clear the calculator before you start solving. So right now, to clear the calculator, the first thing you will have to do will be to press shift first, shift, then this button 9, follow the instruction, want to clear or press 3, press the port again. So now the calculator has been cleared. Next thing we do will be to put the calculator in reduce mode. As you can see, it's in degree. To put it in reduce mode, you press shift mode. Category 4 is reduced. So you press 4. It's now in reduce mode. Very, very important to avoid unnecessary error. So having done this, next thing we do now will be to store a value in the calculator. We store a real number in the calculator we use to differentiate this function. Now you can store real numbers like 2, 3, 4 in that order in a calculator. You can store any of these numbers, but I will advise you to always work with 2. Always store 2 because I have worked with 2 for a long time personally and I have not found any error with it. So I will advise you to be working with 2. But right now, let's store 2 in the calculator. To store 2, you press the number first 2, then press shift, store this button RCL and the alphabet X. So once you do it, here it will indicate that 2 has been stored as X in the calculator. So you wipe it and impute this function in the calculator. So to do that, you first of all bring out the the differentiation symbol in the calculator. So to bring out the differentiation symbol, you press shift this integral button sign, and it will come out d over dx. So you input the function. In function we have cos theta. So there's no theta in the calculator. So we represent this theta with x as we noted here. So to bring out x, we press alpha and x. You have to press alpha first before pressing x. If you don't follow this pattern, x will not come out. If you just press x, x will not come out unless you press alpha first before x. So you close the brackets and come down. We have sine theta, which will be sine x. So you press alpha x, close the brackets, then come back to this place and put 2 restored. So let's press report minus 1.209. So right now we're going to evaluate each and every one of these options to see the one that will give us minus 1.209. So let's start with option A. Option A says minus sine square theta. So right now we have minus sine. Look at how you put it, alpha x, close the brackets, square. So this is how you represent this option minus sine square theta in the calculator, minus sine in bracket x square. So let's press report to minus 0.826. No, this is not what we got. So let's check option B. So it says minus cosec square theta, and there's no cosec in the calculator. That's why I made it to know that cosec theta is same thing as 1 over sin theta. So right now we replace cosec theta with 1 over sin theta in the calculator. So let's do it. So it's starting with minus. So we press minus in fraction 1 over, come down, sine x, alpha x, and close the brackets, square. So minus cosec square theta. This is how you represent in the calculator. Minus 1 over sine x square. So we press report to, we have minus 1.209. So this is what we got when we differentiated. So option B is the answer to this question. So it's as simple as that. Now let's solve one more example and call this a class. So example 2 here says differentiate the function y equals 3 sine in bracket 4 minus 5x with respect to x. So let's bring the calculator and solve this problem together. So we start by bringing out the differentiation symbol. So to do that, I press shift this integral button. So d over dx. So input the function. So we have 3 sine in brackets. So we have 4 minus 5x. So we press alpha x. So you close the brackets. Always make sure that the brackets are balanced before you do the next thing. So as you can see, at the right hand side we have 2 brackets 1, 2, and the left hand side we have 2 brackets 1 and 2. Make sure they're balanced. If they're not balanced, you get error after inputting your values. So having known that, let's continue. We come over to this place and press 2, restore in the calculator, then press report to. We have minus 14.40. Right now let's evaluate these options we have here and see the one that give us minus 14.40. So you wipe this. So let's start with option A. We have 15 cos 4 minus 5x, which is alpha x. So you close the brackets. Now press report. So 14.40. So this is what we got when we differentiated. The difference here is that this one is having minus, that this one is not having minus. Rather, the one we differentiated, we had minus to the answer, but this one is not having minus. So, and option B here is the same. The values we have here for option B are the same for option A. The only difference is that option B here has negative sign. So we don't need to differentiate option. So we don't need to evaluate option B again, since it's already having minus sign. So the answer to this question is option B. So guys, this is how you can solve trigonometric differentiation with Casio calculator. It's as simple as that. Just follow the steps I have shown you in this video, and you'll be able to get the answer correct in any trigonometric differentiation question you are given to solve, especially for multiple choice questions. So that's it for this class, guys. We have come to the end of this class. I hope I taught this topic very well. If you are new to our channel, make sure you subscribe to our channel for more of our videos. Also, like, share, and comment on this video. Comment and tell me what you feel about what you have learned in this class. If you have any specific questions to ask, feel free to leave it in the comment section below. I'll be sure to give you a response.